I'm Ethan Kwan, and today we're going to be going over the solar system. What is it? Okay, so let's go over a quick overview. We're first going to talk about planets and major bodies. Then we're going to be talking about moons that go around those major bodies. And then we're going to be talking about those cute little asteroids. Well, not really cute. So let's first go to the planets and major bodies. Okay, so the biggest object in the solar system is, well, the sun. No, not that sun. Yes, thank you, that sun. Let's go over some sun facts. Orbital data. Length of day is exactly 27 Earth days. Length of year is, well, it doesn't really go around anything except for maybe the galactic center. So if you want, we can put that in here. Yeah, good idea. 250 million years. Okay. It takes 250 million years for the sun to go around the Milky Way galaxy. Well, go around the center of the Milky Way galaxy. Too much information there. Physical data. Radius is exactly 696,420 kilometers. Surface temperature is 5,505 degrees Celsius. Mass is 1.99 billion metric tons. Volume is 1.41 million kilometers cubed. Escape velocity, which is how fast you have to go to lift off the surface of the sun, is 617 kilometers per second, which is really fast. And let's go over the atmospheric composition. The atmospheric composition is hydrogen, mostly. Makes up 73.46%, and helium makes up pretty much the rest of it. Oxygen and carbon make up a little bit, and there's other stuff, but we don't have to pay attention to that. Okay, so let's answer an interesting question. Why is the sun so hot? Now, you might immediately rule this out as the dumbest question of the year, but stick with me here. This is a good question. Why is the sun hot? So let's go on a little aside to answer this question. You see, when the reason the sun is so hot is because, well, it's hot, and the heat produces more heat, I guess. So since the sun is so hot, it makes the atoms jiggle around so much that they can collide with each other. So when they do collide with each other, they produce another atom called deuterium. Now, what is deuterium, you ask? Deuterium is just a combination of hydrogen and a proton and a neutron. Yes. Okay. So hydrogen has deuterium has a proton and a neutron. And with this comes a lot of energy, like a lot. Okay, and that's why the sun is so hot. Let's move on to our next planet, Mercury. Okay, so Mercury, let's go over some Mercury facts. Let's see, orbital data, length of day is 58.8 Earth days, length of year is 87.97 Earth days. Physical data, radius is 2,437 kilometers. Surface temperature is 450 degrees Celsius in day, and it's actually negative 180 degrees Celsius at night. Mass is exactly 330 billion metric tons. Volume is 60,900. Oh, what's wrong with my mouth today? Escape velocity is 4.25 kilometers per second, which isn't that fast. It's still pretty fast. Atmospheric composition, well, Mercury doesn't really have an atmosphere, but it does have a little bit of an atmosphere. It has hydrogen, 99%, and helium, 1%. Yeah, that's it. Okay. Now, one interesting thing about Mercury is it's the most eccentric object in the solar system. Now, what does that mean? Eccentricity is measured from 0 to 1, and eccentricity is measured from 0 to 1, and Mercury's eccentricity is 0.21. What a mouthful, by the way. What does this mean? Well, this means how stretched is the orbit, like how ellipses is the orbit. So for example here, this is a circular orbit with an eccentricity of 0. An eccentricity of 0.21 might look something like this. Actually, no, this is a little bit of an exaggeration, but anyway. What is eccentricity? It just measures how much it's stretched. The way you calculate eccentricity, if you're wondering, nobody is, by the way, is you take the two focal points, measure the distance between them, and then take the distance out of them, like across, and the fraction is the eccentricity. Or more scientifically, it's, if you call this distance C and this distance A, the eccentricity is C divided by A. Okay. So let's talk about our next planet, Venus. Venus is, well, pretty much hell because it's, well, you'll see. Venus facts. Orbital data. Length of day is 243.02 Earth days. Length of year is 224.7 Earth days, which means the year is shorter than the day, which is odd, which means you'll get a birthday even before the year, even before the day ends, which is weird. Physical data. Radius is about 6,052 kilometers. Surface temperature at day is 460 degrees Celsius. Surface temperature at night is also 460 degrees Celsius. Like I said, it's hell. Mass is 4,870 billion metric tons. Volume is 928,000 million kilometers cubed. And escape velocity is about the same as Earth, actually, 10.36 kilometers per second. Atmospheric composition, well, there's a lot of atmosphere. Carbon dioxide makes up about 96.4% of the whole atmosphere, and nitrogen makes up 3.4%, and other stuff makes up 0.2%. Now note that it's 460 degrees in the daytime and nighttime. That's just, wow. Okay. That's because Venus's atmosphere traps heat from the daytime, and it just spreads it all across the planet. That's because the atmosphere has a extreme greenhouse effect, and that's why we should protect our next planet, the Earth. Okay. So, hello home. If you can see yourself on there, say hi. Okay, so Earth facts. Okay, so orbital data. Length of day is a day. Length of year is exactly 364.25 Earth days. Physical data is radius. Radius. 6,378 kilometers. Surface temperature is 16 degrees in the day. And surface temperature is about 0 degrees at night. It depends, of course, in the seasons and all that kind of stuff. But you know that already unless you've been living under a rock for the last few years. Or, I don't know, ever since you were born or something. Mass is 5,970 billion metric tons. Volume is 1,080,000 million kilometers cubed. Escape velocity is exactly 11.18 kilometers per second. And the atmospheric composition is what we're breathing right now. It's actually mostly made up of nitrogen, not oxygen. Oxygen makes up only about 20%, 21%. And argon, which is interesting because argon is weird. Argon makes up about 1%. And water vapor makes up 0.1%, carbon dioxide 0.039%, and other 0.002%. Okay, So, as you might know, that Earth is the only planet we know to have life, and the only planet to have lots of water, like this much water. Well, excluding, only planet we know to have water, excluding these guys. Okay, and lots more. So, let's go on to our next planet, Mars. Mars is, rusty. Weird. Okay, so, Mars facts. Orbital data, length of day is about 24.62 Earth hours. Length of year is 673.78 Earth days. Physical data is, radius is 3,397 kilometers. Surface temperature in the day is about 20 degrees Celsius, mild. Surface temperature at night, though, is 140 degrees Celsius at night. Hope you brought your heater. Mass is 642 billion metric tons. Volume is 163,000 million kilometers squared. That sounds really weird. I got this off the website, so Wikipedia. Escape velocity is 5.022 kilometers per second, which is about half of Earth's, which means it's easier to launch rockets on Mars. Which makes sense. Actually, it makes total sense because the radius is almost exactly half, which means the volume is actually an eighth. Weird. It's math. Don't worry about it. Atmospheric composition. Yes, it does have an atmosphere. Carbon dioxide makes up the majority of it, with nitrogen and argon. Now, Mars has very extreme dust storms. Now, look. Wow. Also, Mars is interesting because it has the largest mountain in the world, in the solar system, actually. Everest is puny. Mount Kea is, Hawaiian Islands, but we don't really count it because most of it is underwater, so, okay. So, next planet is our big friend, or bully, Jupiter. Jupiter facts. Okay, so, orbital data. Length of day is 9.93 Earth hours. Length of year is 11.86 Earth years. Physical data, radius is 71,492 kilometers. Wow. Surface temperature is negative 121 degrees Celsius in the day. And surface temperature at night is even worse. Really hope you brought your sweater. Mass is 1,900,000 billion metric tons, which is a lot. Volume is 143 million kilometers cubed. Escape velocity is 59.523 kilometers per second, which is really fast. Atmospheric composition, hydrogen makes up the most of it. Helium makes up 10.15% of it, and other 0.5% of it. Now, this makes sense because Jupiter's more like a failed star than a planet. Actually, that would be gas giants. Yeah, any kind of gas giant is mostly a failed star. And most gas giants, actually even the ones in our solar system, have this kind of composition. Hydrogen, mostly hydrogen with a little bit of helium and some other stuff. Now, probably the most remarkable thing about Jupiter is its great big red spot, which is enough to fit 3 Earths into it. It was spotted as early as 1655 and could fit over 100,000 Hurricane Katrinas into it. Now, let's go to Saturn. Saturn. Yeah, nice. By the way, Saturn joke. Why did astronomers name Saturn Saturn? Because it had a nice ring to it. Yeah, bad jokes. Okay, so Saturn facts. Okay, orbital data. Length of day, 10.62 Earth hours. Length of year, 29.46 Earth years long. Physical data, radius is about 60,000. Wow, 268 kilometers. Surface temperature in the daytime is about 130 degrees Celsius. Surface temperature at night is 191 degrees Celsius. Mass is 569,000 billion metric tons. Volume is 827 million kilometers cubed, which is a lot. And escape velocity is 35.48 kilometers per second. Atmospheric composition mostly made up of hydrogen and helium with a little bit of other stuff. Now, again, same stuff, right? Hydrogen, mostly hydrogen, a little bit of helium, other stuff. Now, Saturn is one of the most interesting things because it floats, like, really. Like, if you put it in a ginormous bathtub, or if you shrunk it down like this. Aw, look at the rubber ducky. That's a huge rubber ducky. Or a tiny planet. It only has a density of 0.69 grams per centimeters cubed. That's just a measure of density, so yeah. Also, Saturn spins so fast that actually Saturn, the white circle is what you should see. This is what Saturn looks like. Yep. And Saturn's rings are pretty cool too. Here's a human for scale. And here are all the dust particles about ranging in size. This is about how big Saturn's ring would be. All the particles in it, I mean. Okay, now let's talk about Uranus. Now, no jokes. But actually this one's kind of cute. This one's not, though. Okay, Uranus. Uranus. Uranus, not Uranus, or Ura-Nus. Uranus? Huh. Okay, orbital data. Length of day, 17.193 Earth hours. Length of year is 84 Earth years. Physical data, radius is about 25,559 kilometers. Surface temperature is about negative 214 degrees Celsius at night and negative 205 degrees Celsius in the daytime. Mass is 886,000 billion metric tons, and volume is about 69 million kilometers cubed. Escape velocity is 35.48 kilometers per second. Atmospheric composition, again, hydrogen mostly, helium, and a little bit of methane. Now, notice, methane. Methane is this. It's actually the same stuff that comes out of cow farts. Whee! And the same smell as rotten eggs. Which is interesting. Which means that this smells like this. Yeah. Okay. So, yeah, it actually smells like rotten eggs. Surprise! Okay, so, now, here's another question. Why is Uranus on its side? It's actually mostly it's actually tipped all the way around. It's like 90, or like 80-something degrees, 90-something degrees, which is a lot. Because it's actually, because all planets form in the same rotation and the same plane, so it doesn't really make sense for it to be spinned around like that. Why did this happen? Well, probably because something hit it, like that. But more likely, because the rings are still there, because if it was just one hit, the rings would just stay in place. It was more like two hits. One that kind of tilted it, and another one that tilted it all the way. Okay, and now let's talk about the last planet, Neptune. Neptune Facts. Okay, so orbital data. Length of day, 16.1 Earth hours. Length of year, 165 Earth years. Physical data, radius is 24,764 kilometers, or surface temperature is negative 223 20 degrees Celsius in the daytime and 223 degrees Celsius in the nighttime. Now note that it's not really different because the atmosphere kind of surrounds everything and like does another greenhouse effect, kind of like Venus. Okay, so mass is 102,000 billion, or more like 1,002 trillion billion. I'm not sure. 102 trillion. I'm guessing. I'm not sure. Volume is 625 million. Escape velocity, I'm trying to do math. Escape velocity is 23.49 kilometers per second. Atmospheric composition is made up of hydrogen, mostly, helium, mostly, and methane, again, methane. This also smells like rotten eggs. And other, 0.5. Okay, now, note that the most impressive feature of Neptune is the high winds. They are 2,000 kilometers per hour. Wow, that's fast. Now, the SSC Titara, I'm not sure, is the fastest car in the world as of 2020. I know it's 2021. It goes just under 500 kilometers per hour. On the other hand, I don't know cars. I'm not interested. And on the other hand, the fastest plane, the Lockheed SR-71 Blackbird, fastest plane in the world. By the way, correct me if I'm wrong on any of this. In the comments. Is 3,500 kilometers per hour. Goes at 3,500 kilometers per hour, which is actually much faster. Okay. And now we get to our final planet. No, not planet. Dwarf planet. Pluto. Okay, so Pluto is not a planet. I just wanted to include him in there because, well, Pluto. Okay, so orbital data. Length of day is 6.38 Earth hours. Length of year is 248.5 Earth years. Physical data. Radius is 1,100, I guess, kilometers, 11.500. I'm not sure. Yeah, you figure out a way to say it. 105 tens. I don't know. Surface temperature, negative 218 degrees Celsius in the daytime, and negative 240 degrees Celsius at the nighttime. 13 billion metric tons is the mass. Volume is exactly not exactly. Why do I keep saying exactly? 6,160 million kilometers cubed. Escape velocity is 1.227 kilometers per second, which is pretty slow. Atmospheric composition, it doesn't really have an atmosphere, but mostly made up of nitrogen, and carbon monoxide and methane, 10%. Okay, now we've reached the end of our first section. Let's go to our second section. Moons, they go around and around. Now, first of all, we have to define what a moon is. Now, there is a wild discussion online with a great video from Minute Earth about what we should define a moon to be. Great video, by the way. You should watch it. It will be in the comments. It will be in the description below. Okay, but our definition will be a moon is an object orbiting in a circular or elliptical orbit around a planet where the planet is orbiting a star. And the moon, yes, I know, I added a period and a comma. And the moon is at least 2/3 as small as the planet. So, for example, this is a moon, but this is not a moon, and this is definitely not a moon. Now, first of all, get things out of the way. Mercury and Venus do not have moons. So let's move to Earth. Earth has one moon. Earth's moon, moon. Yeah, moon. Yeah. Okay, so, moon. Moon facts. Okay. Orbital data. Well, this will be how long it takes for it to go around once. So length of day, well, how long it takes to spin around is 27.32 Earth days. Length of year is 7.28 Earth days. Physical data is radius 1,738 kilometers. Surface temperature 23 degrees Celsius in the day and negative 233 degrees Celsius at night. Mass is exactly 7. What? If I say exactly again, just ignore the word, okay? 74 billion metric tons. Volume is exactly 22,000 million kilometers cubed. Escape velocity is only 2.375 kilometers per second. Atmospheric composition is mostly helium, actually half helium and half argon. Now, there are many theories for how the moon formed. This is my favorite, and probably the coolest and probably the most reasonable. The moon was actually another object that actually slammed into the Earth and caused a big thing to come up from the Earth. And it hurt the Earth, of course, but the Earth healed. Of course, it's green right now, which means there was probably life back then. And all this material coalesced into a ring, into a circle around Earth, and this stuff coalesced into many objects, which coalesced together into one moon. Woo! Okay. Now, next planet. Mars has 2 moons. Mars has 2 moons, Phobos and Deimos. Let's start with Deimos, because why not? Deimos is cute. Well, kind of depends on your definition of cute. Deimos Facts. Orbital data. Length of day is 1.26 Earth days, and year actually, 1.26 Earth days. Physical data, radius is 3 kilometers. Mass is 2 million, only million, metric tons. Escape velocity is actually 0.01 kilometers per second. I know. And let's go to the other moon, Phobos. Phobos is interesting that it's also the same. Actually, most of the moons are the same. Length of day and year are the same, 0.32 Earth days. Physical data is radius is 11 kilometers. Mass is 11 million metric tons. Escape velocity is 0.011 kilometers per second. Yep. Now, Jupiter. Jupiter has many moons, like lots. Stop hogging all the moons. But I want to focus on 4. They're the biggest ones. So let's start with Io. These are the 4 Galilean moons, by the way. Orbital data. Length of day and year is 1.77 Earth days. Physical data is radius is 1.8 K, or 1,000. Mass is 89 billion metric tons, and escape velocity is 2.588 kilometers per second. Europa, orbital data, length of day and year is 3.55 Earth days. Physical data, radius is 1.5 K. 48 mass is 48 billion metric tons. Escape velocity is 2.026 kilometers per second. And finally, Ganymede. Okay, so Ganymede, orbital facts. Let's see, length of day and year, 7.15 Earth days. And the reason, actually, I forgot to mention this, but the reason they're almost the same is because most of them are tidally locked. I should make a video on that. Okay. Basically, if a video does come up on that, you should watch that one. But basically, it means that one side of the moon always faces the planet. It's kind of like staring at a planet. Kind of rude. Okay. Physical data is radius is 2.631 kilometers. Mass is 148 billion metric tons. Escape velocity is 2.742 kilometers per second. There we go. And finally, we get to Callisto. Callisto, orbital data. It looks awesome, by the way. Length of day and year, 16.69 Earth days. Physical data, radius 2.4 K. mass is 108 billion metric tons. Escape velocity is 2.441 kilometers per second. Now, let's go to Saturn. Saturn has also many moons. Again, we should stop. It should stop hogging them. Let's focus on two. The first one is Titan. Titan is awesome. Titan, orbital data, length of day and year, 15.88 Earth days. Physical data, radius is 2.5K. Mass is 135 billion metric tons. And escape velocity is 2.645 kilometers per second. And the other moon is Enceladus. Enceladus is cool. Literally. Orbital data, it's icy. Orbital data, length of day and year, 1.37 Earth days. Physical data, radius is 250 kilometers. Mass is 110 million metric tons, which is a lot, actually. Escape velocity is 0.242 kilometers per second. Now, Enceladus is actually pretty small. 250 kilometers, that's pretty small. For a moon, anyway. That's pretty big on a human scale. Okay, and now let's go to Uranus. No, Uranus. No jokes, please. No jokes. Okay, so one of the moons of Uranus is Titania. Titania Facts. By the way, the name, cool. Orbital data, length of day and year, 209 Earth hours. Physical data, radius is 788 kilometers. Mass is 352 billion metric tons, and escape velocity is 0.773 kilometers per second. Now, let's go to our Neptune. Alright, so Neptune. Let's see. So, probably the biggest moon would be Triton. Triton Facts. Orbital data. Length of day and year, 5.88 Earth days. Physical data. Radius, 1,353 kilometers. Mass is 21 billion metric tons. Wow. Escape velocity is 1.453 kilometers per second. Now, no, the reason that Triton is interesting isn't because of some weird fact in its orbital data or physical data, because none of those are really interesting. It's pretty normal for a moon. Okay, the reason it's interesting is that, well, you'll see. No spoilers. So most moons orbit in this fashion, right? Around in a clockwise direction. Now, Triton, interestingly, orbits in a counterclockwise direction. Or is it? Yeah, I'm not sure which way it actually does. I'm sorry. Anyway, it orbits in the opposite direction as every other moon, which is weird. One way this could have, well, the reason this is odd is because all the moons form out of the same disk as the planet, so they should all be orbiting in the same direction because they all formed from the same disk, like this, as you can see. By the way, don't you think this simulation is pretty cool? I made it. Yeah. Whee! Okay. So, as you can see, Neptune's got one moon orbiting it, which is nice. And the other moon should come back any second now. Where's the other moon? Oh, there it is. And, oh dear. Okay. Okay, anyway. I wonder when the simulation will land. One sec. Let's just wait for it. Anyway, this is how moons form. Whoa, that was a nice collision. And most of them coalesced onto the big moon. Okay. Oh, there's the other big moon. Wah! Okay, I think that's enough. Okay, so the one way Triton could have formed is that it was actually a binary, but it kind of did this. Whee! And one of them started orbiting, and the other one just flew off to infinity. Okay, so that was kind of a boring simulation, but anyway, there we go. Done. Okay, so next. Next is, well, we're done the moon thing, because technically Pluto does have a moon, but it's not really a moon. It's more like a binary pair, so we're not going to count that. So now let's go to teeny tiny asteroids. Now, the first asteroid was discovered in 1801. Astronomers knew of planets and moons, ants. Yeah, I was sleepy when I was typing this. But there was something new around the sun. Thousands upon thousands of rocks ranging from 2 meters to 900 kilometers. Physical data. Number of asteroids around 1 million. And total mass is about 3 billion metric tons. Now, most moons are located in 2 regions, the asteroid belt and the Kuiper belt. And most of these asteroids just came from the formation of the solar system, like this. Wee, wee, wee. And, yes, this is an actual simulation that I made. Kind of boring. Now, most of these asteroids coalesce together to form planets, and this is kind of a long simulation, so you might want to speed up your video for this, but I'll talk slower if you are going to do that. But anyway, most of these asteroids actually made moons, as you can see, and these should be actually called protoplanets, because they're not actually the right size to be actual planets. Once they collide with other planets, though, they do become planets, like this one. This is a bigger planet, sure. It's still kind of a protoplanet, though. Oh, there we go. Now it's a planet. Yeah, so as you can see, most of the planets in the solar system had very violent endings. Let me just go all the way here. Yeah, there. Yeah, it's just a big collision. Let's see. Whee! Oh wow, it's a really big collision. Okay, then. Okay, there's something escaping, and there's another asteroid. Okay. Anyway, next slide. Okay, so most of the other ones just piled onto the planets like that. Yeah, that was a planet. But some got trapped in traps. Well, that's kind of obvious, isn't it? These traps are called Lagrange points. Now, what are Lagrange points? Well, they're represented with L's. Interesting. Never expected that. Okay. These Lagrange points are here. There's one here called L1. There's one here called L2. And there's one here called L3, all the way across. There's here 60 degrees ahead of the planet called L4. And 168 degrees behind the planet called L6? No, 5. Yeah. Okay. Then we have these 2 points. These are where most planets have captured asteroids, because these points here are gravitationally safe zones, because there are no gravitational forces acting on them here at these 2 points. So actually, Jupiter has a big collection of asteroids around there. Now, these asteroids are called the Trojan asteroids. Wow, where did I get these jokes from? Okay then. Okay, so these are called the Trojan asteroids. Okay, thank you for watching. I hope you liked this video. If you did, please hit the subscribe button and make sure to hit the bell notification for to not miss any upcoming videos. And don't forget to like this video too. Click. Okay. And other than that, thank you for watching, and also see you at howtodosomething.com. See you next time. Bye.